Okay, students, good morning. Today's session we are going to discuss about the A-star search algorithm. This is also one of the best example for this the informed search algorithm. Search algorithm. So, in the best of a search, there should be a simplification of A-star algorithm. So, this A-star algorithm was introduced by Hart, and here the main objective of this. The informed search, we are going to find out the heuristic function. The heuristic function has to be uh, uh, defined with this. So the notation can be represented as f of n. So f of n is equal to g of n plus h of n. So what about the g of n means we need to find out the cost so far for the to reach the node of n, and h of n means the estimated cost from node n to the goal state or the goal node. Okay, so we just note down that kind of things. So f of n is equal to g of n plus h of n. So g of n means this is a cost so far to reach n. So h of n is then is the estimated cost from n to reach the goal node. So the best search is the special case of A star. That is f of n is equal to h of n. Okay, so you just note it down for the process. Another one more thing is that, so what about the A star algorithm? So the A star algorithm has to reach on this, that is we need to repeat the process to get the goal. So if no nodes are existing in the open list, so return failure to reach the goal, or otherwise we need to proceed on this. So select and remove the node from the open list with the lowest f value, and we need to call the values of x with the current node or the c node. Put c node to the closest list and check if the c node is the goal node not, so we need to stop it, or otherwise if it is not then guarantee the successor for the c node, and for every successor also. So we need to save the path from the successor to the c node, and calculate the G successor of G C node plus cost to reaching the successor from the node also. So what we are going to do this, so repeat, uh, do till we get the goal. So if the no nodes are existing in the open list, so return failure to reach the goal. Else means select and remove from the open list. So with the lowest f value. So let us call this let us call this node of the current node or the C node. So now the C node that is in the closest node. So we need to check the goal node. If it is not there, we need to generate the successor of the C node, and that should be added in the and we need to find out for every successor. So save the path from the successor to the C node, and calculate the G successor is equal to G C node plus cost of reaching the successor from the C node. So what about we are having the three different cases. One is this check if the successor is open list. Now this means the node has been generated previously and that should not be considered. So if so, we just to throw this node into the and add it to the C node successor list, and the decision that should be taken to connect the path between the P nodes parent to the C node. This is the case one. Case two means check if the successor is only the closed list. If the node is the parent on the closed list, let us call this node as P node. So add the node to this C node successor, and again check the cost as we have done in the previous steps also. So accordingly, update the G and F values also. So we just consider this value. So this is second one, and third one thing is uh, check if the successor is neither in open list nor in the closed list. So simply we just add it in the open list, and the list of C node successor. So f of successor is equal to G of successor plus h of successor and proceed. So these three cases are considered for solving this problem. So this is the problematic function. So the example, there is the same example. And there is the first node that should first figure that should represent the heuristic function, and second node that should represent as an the cost function that should be combined together with the help of this function. So initially, our aim is to we just reach to find the path from home to university. These are all the heuristic function. These are all the cost that is associated with each and every link. So we need to find out that. So first initial node is home and goal node is university. You just note it down. So what are all the steps that should be considered? So the step one is initially the home node. So the cost function is 0 and the heuristic function is 120. So 0 plus 120, you just add it. So that should be a 120. So step 2, we need to find out the successor of the node home. So what are all the successor? Bank, garden, and the school. We just note it down. For this node, bank to home, home to bank, we have the heuristic function is 8. Here, home to bank, this is a cost function is 45. That is 80 plus 45 is 125. So you just note it as 125. And home to garden is 100 plus 40, 140. You just note it on 140. Yes. Home to school is 70. Here, home to school is 50. That is 120. So you just note that is which one is more minimum. So you just select this one, school. Now we are able to find out the school value. And here 125, 140 and 120. So which one is minimum is 120 is minimum. So I just select this school. So for considering this school, so you may have the two options. There is railway station and the post office. Railway station, school, there is what about the school? We may have the three option. Three successor: home, railway station, and the post office. So you just note it out. Okay, so for these aspects, home to school and school to home, there is 100 plus 120. And 100 plus 120 is 220. You just note it down. And home, school, home. Okay, so home, school, home. That is home school. Already we find it is 120. No, okay, so 120 plus the initial value is 100. So 100 is Mm, So 100 na. Yes, 100. So you just note it down. So that should be 100 plus 120 is 220. So after this, we need to find out the path from home to railway station. So 125 to 20. 125 to, yes, 125 to 20. You just note it down. Another one more thing is here, there is home, school, and post office. That is 110 plus 108. Yes. 110 plus 108. So 219. So which one is among this? Which one is minimum? 219, 245, 220, 140, and 125. So bank is minimum. So we just note it down by step 4 and step 5. Okay. So for considering the step 4, so again, the bank may have the two option. One is home and the police. So here the cost. So bank to police. So bank to home. That is bank to home is the 80 plus. So 45. That is you just note it out. That is 120. Here 120 plus 90 is 210. You just note it out. And bank to police is 105 plus 26, 131. So you need to compare. These are all the closed nodes. So these are all the terminals are then open nodes. So 210, 131, 140, 220, 145, and 219. So police 131 is very minimum. So again, we just expand this. So police here you just note it on. So we just take it as the police means we just take the two option. Here So one is bank or there is another one more thing is bank or university. You just note it down. Bank or yes, bank or university. So you just noted there is 165 plus 80 is 245. Here 133 plus 0 is 133. So which one is minimum is 133. So we reach the destination. So no, we can stop this process. So this is a path. Lengthiest path is that home, bank, police, and then university. So this is the path we are going to reach our destination. So this is the way we are going to find out our uh, the process. So in this methodology, you just find out. We just give the importance for this the heuristic function. The heuristic function plays the major role on this. So you can note it down. And the heuristic function may have f of n is equal to g of n plus h of n. So f of n may be and the cost so far to reach the value of n, and h of n is to estimate the cost value from the node n to the goal node state. Okay, so you just from this value you just apply the algorithm, and from this algorithm you may able to find out the three different cases. So you just note it down. And for this example, we are having the heuristic function and the cost function. And from this cost function, we need to find out the shortest path from home to university. You just apply this algorithm to find the very shortest path for finding this method. So finally, we just take the answer is home, bank, police, and the university. So the minimum is 133. Okay, so this is a one important point that should be considered for our process. Okay, thank you.